how are we going to actually slice this into smaller pieces? There's really three different ways that you can do this. I mean, there's lots of different ways you can do it, but there's three main ways that people do it. So slicing this into smaller pieces. These are some of the commonly used smaller pieces that we use. In this case, daily standard deviations. You're looking for a daily standard dev. That's how much expectation of movement you can expect on any normal day, any normal trading day that's happening. That's the square root of 252 because there's 252 days, trading days in a year. What if you wanted to think about it in weekly terms? You would do the exact same thing, but instead of the square root of 252 in the denominator, you would use the square root of, you guessed it, 52. Why? Because there's 52 weeks in a year. So you could divide it by the square root of 52, and then you would have an expectation for how much that thing might move on any given week during that period. One final way that some people like to think about this is a monthly standard deviation. If you're someone who looks at your position once a month and you want to know how much movement can I expect for any normal month in the year based on this implied vol number, guess what? You can do that too. You can subset this annual variance number into 12 individual sections by dividing by the square root of 12 because there's 12 months in a year. It's really just the idea, and this is what I want to transmit to you. You're taking an annual block and you're slicing it into smaller blocks. That's really all we're doing here. But it gets a little complicated when people start to look at the math of it, and that's part of the reason why I like to break it down into pieces first. So when we're breaking down this annual variance, a lot of people will ask, why do we use the square root of time? Why don't I just divide it by 252? The reason why is because variance is the actual expected value of the squared deviation from the mean. And so when you create this annual variance number by multiplying those two numbers together, remember the implied vol times the actual asset price times the underlying price, what you're ending up with is an annual variance number that is the actual, the sum of the squares, right? And so when you want to actually subset that into smaller pieces, in order for the mathematics to work, you actually have to divide by the square root of time of those time periods in order to remove that squared function from the numerator of the equation. So to remove the squared nature of the total annual variance, you also have to divide by a square root of some type. Standard devs are the square root of the variance. So this is why we need to use this to slice this down into smaller pieces. That's the reason why, that's the answer to the question of why the square root of time instead of just time. So once we take a look at this and we're able to actually build some understanding around it, we're able to get into the weeds a little bit and think about this from the perspective of how you might use this on a daily basis. So converting this to an actual daily standard deviation, in this case, like I said, we use the square root of time in the denominator. To get to the daily standard deviation, we are using the square root of 252, which is actually 15.8745. For simplicity, and because, like I said, it just rolls right off the tongue, we're going to call it the rule of 16, and we divide by 16.